Hello everyone, this is John Faulk here with JagSuccess, and today we're going to be going over a fairly complicated subject matter from Calculus 1 known as Riemann sums. And Riemann sums are basically, we are going to take an integral, so let's go from a to b of some function, and we are going to estimate it using Riemann sums. So we'll go from k equals 1 to n of f of c sub k delta x. Alright, so let's get some background here. N is going to be the number of rectangles that we will use. K is the index number. Delta x is going to be b minus a over n, and ck, c sub k, is going to be a plus delta x times k. And our index numbers, k, is going to go 1, 2, 3, and so on, up until the number of rectangles that we have. So let's see what we're actually doing here. If we have a graph, okay, so let's say this is 1 and this is 2. Let's say we have the function f of x equal to x squared. Well, here we would have 1, and then here we would have 4. So if we graph this function, it'll look something like this. Alright, so using Riemann sums, what we're going to do is we're going to basically make these into rectangles. So as you can see, we have one rectangle here, which is very small and you can't see it. We have one rectangle here, one rectangle here, and one rectangle here. So our number of rectangles that we have is 4. So our index k will go from 1 all the way to 4. We see that b is equal to 2, and a is where we start, which is equal to 0. So let me get rid of some of this stuff up here. So in this example, we're going from 0 to 2 of x squared dx, and we can find an estimation by using the sum from k equals 1 to 4, since we have 4 rectangles, of, so this is f of ck delta x. Alright, so now we have to figure out what delta x and ck is. So we have delta x is b minus a over n. So we'll have 2 minus 0 over n, which is 4. So this is going to give us 1/2. So let's put this down here in the bottom so we can remember it. Alright. So now we have to see what CK is. Well, CK is going to differ based on the index. So if we start with, let's see here, let me get rid of this over here. If we start with the first index of C, which is C1, we'll have A, which is 0, plus delta X, which is 1/2, times K, which is 1 for our first index. So that will give us 1/2. Now we go to C2. And C2 is A, which is 0, plus delta X, which is 1/2, times our index is 2. So 2 times 1/2 plus 0 is 1. We're going to look at C at our third index. And it's going to be A, which is 0, plus delta X, which is 1/2, times our index K is 3 now. So this will give us 3/2. Now our fourth and final index, because we have 4 rectangles, it's going to be A, which is 0, plus 1/2, which is delta X, times 4, which is our index, and so 0 plus 2 is 2. So now we have to evaluate f of CK at each one of these C's. And as you know, our function of x is x squared. So f of C1 is going to be 1/2 squared. Let me get rid of some of this over here so I can have some room. Alright. So this is going to give us 1/4. F of C2 is 1 squared. And all we're doing is we're putting 1/2 in for x, and 1 in for x. So this would be, if we put 1 in for x, it would be 1 squared. If we put 1/2 in for x, it would be 1/2 squared, which is 1/4, and that's all we're doing. So this is going to be 1. F of C3 is 3/2 squared, which is 9/4. And f of C4, our last one, is 2 squared. So 2 squared is 4. Alright, so now we have all of our f's evaluated at our indexes. So now we just have to multiply all of these by delta x. So if we multiply this by delta x, we get 1/8. We multiply this by delta x, we get 1/2. Multiply this by delta x, we get 9/8. If we multiply this by 1/2, then we get 2. And our last and final thing that we have to do is we have to add all of these together. So we found C sub k for each of our indexes. We evaluated those in the function x squared, which gave us all of these numbers here. And then we multiply all of them by delta x, which is right here, which gives us these numbers. And then we just add them all together because they're a sum. So up here, well, actually, let me just get it over here. Alright. So, now our estimation for this definite integral is going to be 1/8 plus 1/2 plus 9/8 plus 2. And this is going to give us, if we put it in the calculator, 1/8 plus 1/2 plus 9/8 plus 2. This will give us 15/4, which is 3.75. And this is just an estimation using 4 rectangles. If we were to evaluate this, this definite integral, our answer would actually give us our real answer is 2.67. So you can see that estimating actually gives us a pretty big gap. And what the theory states is that the more rectangles that we use to estimate this, the better estimate that we get. So if we take these number of rectangles to infinity, we would actually get the rectangle, or get the answer 2.67, which is our answer to the definite integral. And that is actually how integrals were formed, by using these estimates of Riemann sums and just taking the number of rectangles to infinity. So why do we get 3.75? And that is because when we did our graph and we took these small rectangles let me get a better drawing for you. That's kind of bad. Let's see here. Okay. There we go. So actually what we did was we made rectangles two, three. Actually, this one extends all the way over here. So we made 4 rectangles, and you can see that we have actually overestimated by this much in each of our rectangles. And that's why we get a larger answer than our real answer. Now there's another way. This is called right-hand sums. If we use left-hand sums, then our C sub k would change to B minus C sub k delta x. Or I'm sorry, not C sub k, just k times delta x, instead of C sub k is A plus k times delta x, like we did in this video.